Hello everybody and welcome back to Science Live. We're here again coming to you from the Creation Museum down in the Science Education Lab. And it's the weather's changed a bit in the last couple days. We went from sunny to very chilly while I was out for a walk last night with my wife. I've got Dr. Georgia Purdom with me again today. And we are here trying to encourage families to learn more about God's creation and help you see how the world around us has been created in amazing ways. Dr. Purdom will be taking your comments as they come in, if there are any questions. Got a really cool comment yesterday from someone who said that their kids wake up every morning and ask if it's 10 o'clock yet, waiting for the program. So that's very encouraging. Thank you for sharing those things. And we just hope that this is a blessing and that you can be learning something, especially together as a family. But then for all of the 5 and 6 and 10-year-olds, there have been some older folks as well joining us and learning who admitted not their exact age, but I'm an older person and I'm really loving this and enjoying this. So glad we can do this for all ages and engage those things and help understand about God's creation.
And be sure to share this on your Facebook page because that gets us out there more, it gets more people to know about it, and so that's really important. Maybe even do a watch party. Now you can't all be together, okay, but you can invite your friends to do the watch party from their location and learn more about God's world.
Yeah, so share that. Don't forget to like the videos, and that always helps increase the exposure to them as well. All right, we are going to get started today. Our topic today is flaming metals. So you can imagine there's going to be some fire. I
love this, and I'm not a chemist, but I love this.
Fire and fun things. So what we're going to be talking today is about signatures that God has placed in every element that He's created. So every element has kind of its own fingerprint. Right. And we're going to talk about that chemical fingerprint that every element has. And it has to do with the way each atom of each element is structured. So remember that an atom is the tiniest portion of any substance that we have. If we split a piece of salt down in half and half and half 1 billion times, more than that, many more than that, we'd wind up with a molecule of salt that has a sodium atom and a chlorine atom stuck together. And then each of those sodium atoms has within it a nucleus. So we can think about the center being a nucleus, and inside of there we have protons and neutrons, so that's the positive region. And then out here in this area we have an electron cloud. So this would be a spherical structure. We've only got part of it represented here. And each of those elements has a different number of protons. That's what tells us what element it is. And because it has to be neutrally charged, the same number of positives and negatives, it has those electrons arranged in these energy levels. So we're going to talk about how that structure of energy levels helps us identify different elements. So we think about the periodic table here. We've got a picture of it here. Each of the elements in the periodic table has very specific characteristics. So everything over in this group here, we call the columns going up and down groups, everything in that group has 1 electron in its outer shell. Everything over here has 7 electrons in its outer shell, and everything over here has 8. So the group numbers help us tell that. These guys in the middle, they're a little weird, so we try not to talk about them too much. But everything in the period has the same number of energy levels that its electrons are arranged into. So this is our organized structure to help us describe how God's created all of these elements all around us.
And we're still finding those elements. Like that's what's really neat too. I was saying I found an old periodic table from when I was in college, and it didn't have all the elements on it that we have today because those have just were theoretical, but now they're reality. So it's neat to see how we're still discovering these things.
Yeah, definitely. Okay, so if we go back to here, we think about the electrons that are hanging out in an energy level. If we add energy to something, that's going to increase its energy. So ways we can add energy are things like electricity and heat. Those would add energy to a system. So if I were an electron hanging out down here on level 1 and energy was added to me, what do you think would happen? Well, I would jump up to one of these other levels depending on how much energy was added. So if something goes up, what goes up must come down. Okay, that's the tendency. So once we add the energy is given off. And we know from the law of conservation of energy that anytime energy goes up or down, it can change forms. So the way that we see this change of form is as the energy goes from level 4 down to level 1, it shoots off a little particle of light we call a photon. So different jumps, if I fell from 5 down to 2, that would be this much energy change, and that would give us a certain photon of light that would have a certain color. If I fell a shorter range, that would have a lower energy, so that would be more toward the red end of the spectrum. And so every element that we know of has its own chemical signature. And this is a little kind of a chemical fingerprint. We call this a spectroscopic image, of spectral lines. And these spectral lines, you can see these bright areas in here, are different for every element based on the different electron layers and how the electrons move when they're excited. So we can identify all of those different things based on their chemical properties, the electron properties especially.
Okay, we have a question.
All right.
So Terry, age 11, wants to know what an electron cloud is.
Okay, so if we think about, I don't have a little ball here. If we had the nucleus of an atom, think about that as a tiny little ball. The electrons are negatively charged, the nucleus is positive. So opposites attract, and those electrons are attracted, and they just hang out in kind of a cloud around it. So think about a sphere, and each of these energy layers would represent a little sphere inside of a sphere. So if you think about a BB with a tennis ball around it, with a volleyball around it, with a beach ball around it, the electrons would exist in those layers. Now it's much more complicated than that.
Oh yeah,
I
remember that.
That's a very simple model of how the electrons work, but it helps us describe these spectral lines.
Okay, Evan, age 12, wants to know, is this how glow-in-the-dark items work?
Yes. So the light that is emitted there is because electrons are being excited and then drop back down. So if you think about a firefly, there's a chemical called luciferase that's in a firefly's backside, and that's activated by a catalyst, and then that gives off that light and causes that light emission.
Yep, that's good. That's all we have so far.
So this picture that we see here, all of these different structures, all these different lines can be measured. You notice we have a spectrum from red, orange, yellow, green, blue, indigo, violet, that typical spectrum that we talk about when we're talking about visible light. Well, this over here is the fancy device that would help us to observe that. So we would point this end at a light source, and we'd look through this end with our eye, and we would see inside of here one of these spectral line images. So something like this would show up inside of this device. And this is actually marked out so that we can measure the different wavelengths of light. And we know that light we can measure with wavelengths. And on the red end of the spectrum, we have, this actually has a little scale for us. This is a similar type of thing. So this little screen right here is actually similar to what's inside of this device, but it's just something you can hold up to your eye and look through. And I can look at the lights up in the ceiling, and what do you see, Dr. Purdom?
I see rainbows, basically.
We see a full spectrum because the lights above us are white light. They're giving off all those different colors. But if we had a light that was a specific color, it would give us a very specific line spectrum. And I'm going to set this off to the side.
Everyone's seeing Claude, so that's good.
Claude's here.
Yep.
Okay, Claude's going to be joining us in a minute. Yep. This is a type of fun glasses you can get, and people put these on. If you look online, they're called like firework glasses and things like that. But they basically have this little filter. So what this is it's a sheet of plastic that has thousands of little lines of prism lines cut across it, and high quality ones would have many more lines per millimeter than these little ones that we have here. And we'd get better results. So Claude's going to join us today, and he's going to hang out over here. He's going to put on his spectroscopic glasses, and he's going to watch with us. So we're going to do the rest of the segment in the dark. So
just to warn you.
Just to warn you, things are going to change. Our faces will be a little dark, but we're still here. And I'm going to turn on this light over here, and inside this light, I have a tube of neon gas. And if I excite those electrons in the neon gas by using electricity, we can see that it causes them to give off light. And this color for neon is a very signature color. So when we talk about neon signs, we often talk about things that have lots of different colors, but really neon is the gas that's inside of here. It's one of our noble gases. So you could take that filter, and we're going to do this with the camera in just a second. Look at the light and then pan over here about 20 degrees. So look right at the light and then turn your head toward me. Toward me. Turn the filter toward me this way. There we go.
Oh, yeah, I see
At about
it now.
20 degrees, you should see a clear line spectrum with lots of reds and
Lots of
yellows
reds.
in there.
Yeah, oranges.
Okay, so we're going to try and do this with the camera for you. So the cameraman's got to get his skills on here. So he's gonna unhook from the tripod. He's going to come in close with the camera and then put the filter over the top of it. And he's going to move in, and I'm going to hold up a black lab apron over here so that you can see this better, and you don't have to look at my face very close. Okay? And as he comes in here, you should be able to see, he's going to pan over, and you should be able to see that very clear line spectrum showing up in the middle. Are we seeing that there? We getting a good image there? Oh, hold on just a second.
Okay.
This is a little tricky with the camera. Okay.
Yeah.
So and as he comes in and pans over here, you should be able to see a very clear line spectrum. That's the signature line spectrum that we would see with the gas neon. Now, let's change this out.
There it is.
For a different gas called argon. And when we put the argon in there, you can see it's a different color. Now this is a much fainter spectrum, but hopefully you can see it there. You get some different colors. So every different element, as it glows, and those electrons get excited, and then they fall back down. Just like you kids, if you get too excited, you get all that energy out, you crash and need a nap later. Okay? I think that's pretty true for me as well. But those electrons are being excited and falling back down. So you can see that signature line spectrum that we see with every different element. Okay? We'll go ahead and turn that off.
That looked very neat on the, that
right.
you could actually see it. It's very neat. Now, somebody asked, what is a spectrum?
Okay, so the word spectrum is just a word that we use to describe something that happens across a range. So if you were to think about height, you could probably line up your family in order from shortest to tallest. We'd say that's a height spectrum. Okay? My family, it's pretty flat. Down to my wife.
Tall.
All my kids are over 6 feet tall. Even my daughter is 6 foot. So ours is pretty flat, but we could get a larger family and see that whole spectrum of sizes. So a spectrum, when we talk about it in light, is if we pass white light through a prism, it separates out into all the different colors that we think of, and that's what we see when we look at a rainbow. So a rainbow is a specific phenomenon that's a spectrum of light that we see in the sky when there are water droplets suspended around, whether it's a garden hose or a waterfall or a storm system. Okay, now here comes the fun part.
Yeah.
This is where we get to burn stuff. So I'm going to set some of these papers aside. We are going to put on our safety glasses now because we're going to be working with some chemicals. And what we have inside of each of these little beakers from these jars are a bunch of different salts. A salt is a general word that means a metal mixed with another compound, another atom, and they are typically things that are halogens, so things that are clear over here on the periodic table mixed with metals. So we get this reaction, we call those things salts. The one you're familiar with is table salt, is sodium chloride. We're going to put these different salts into this flame, and you're going to be able to see their signature color. Now, if we could set up the spectroscope and see the camera, you would actually see different spectral patterns like we saw with the different lights. But that's too hard to do because these flames happen really quickly, so we can't do that through the camera. But we're going to go ahead and ignite this. You got your igniter ready? Okay. Okay. So what we're going to do, we've got these little nichrome wires here attached to a piece of cork to keep them from burning our hands and to be able to sit on the table quickly. And I've got a little beaker of hydrochloric acid right here, so we're going to dip that in there and make sure our wires are clean so that we have a clean signature. Now that color is the color that the wire is going to burn. Okay, it's a nickel chromium wire, and we're going to clean those off between each one. So here I have in this one barium chloride. Okay, this is an undertaker's favorite element. Barium.
Oh,
Bad
we got
chemistry
a pun
jokes.
in there. Okay.
So when I put barium into the fire, we get that there's a little flash, and this is something you might have to rewind. If you're watching the video, go back and rewind and pause it. Oh, that we didn't get enough on there. Right in the middle here.
There we go. Oh,
that
there you go.
orangish green color that you're seeing in the flame. And then as that burns off, we lose some of that. Okay, that orangish green color. So that's a signature color for barium. Which one do you have there?
I have lithium chloride.
All right.
All right, here we go. Sure, I got plenty on there. Woo! Bright,
Okay, so that's a bright reddish color.
red. You can see that.
All right, give it one more dip there.
All right.
I'm going to clean mine off while she's doing that.
Pretty one.
Okay, that bright red.
Red.
Yeah.
All right.
Kind of a reddish purple color. So if we did that and we looked at the spectral lines, I'd expect to see a lot in the violet range and in the red range mixing together there. That one's going to take a minute to burn off.
I
So
know,
go ahead
I'm
and
noticing
stick it in
that
there.
because it's still really red there.
Yep.
There we go.
Okay. Okay, so here I have, this one is strontium chloride. This is another fun one. Another bright red color, but you can tell there it's not quite as purplish as the barium ones. So we get that nice bright red color. Okay.
All right.
All of these. Okay, go ahead. Yep.
So mine is table salt, sodium chloride.
Sodium chloride.
All right, so here we go. Really bright yellow.
Yeah, that bright yellow color, that's a signature of sodium. That one's pretty obvious. I'm going to clean mine off again here. All right, looks like we're good.
I'm going to clean mine.
All right, this one is potassium chloride. So we've got potassium here, and that's going to give us a purple flame. See that little light purple color that came in there at the beginning?
Oh, yeah.
Neat.
There it is.
Neat purple color. Okay,
I have copper chloride.
Now, let me stop for just a second. Most of these are just white salts. If we look at the little crystals of them, they're just little white crystals like table salt. That one has a bit of a greenish color, and the other copper one has a bluish color. So let's go ahead and see what the copper is going to do.
All right, I got plenty on here. Ooh, look at that. Did you see that? That was cool. I'm doing that again. So somebody said they've been watching and their child now wants to do chemistry.
Oh, that's good.
You just made Roger very happy.
We need more scientists who are into
There we go. Look at that pretty green.
Okay. So now that's copper 1 chloride. This is copper 2 chloride. If copper gives us a signature color, what would you expect the color of this flame to be? It should be very similar to the one we just saw. And indeed, we get that greenish flame. Right? Even though the salt is blue, when the electrons are excited, they give that green flame color. So
Okay,
copper, signature green color.
This is a good question. Well, they're all good questions, but this one's especially interesting, I think. Are different salts in those packets you throw on a campfire to get different colors?
Yes. Okay,
Bingo.
so you can buy little fun packs where you put this packet of salt and there are mixtures of different salts in them, and those would give us different colors. All right, I think the last one we've got here is calcium chloride. This is what you might buy as a salt to put on your driveway to clean off the ice, unless you live in Florida, then you don't know what we're talking about. Okay? So that there was something contaminated in that one there. Okay? Get that nice bright orange flame out of the calcium. Calcium and sodium are kind of similar to one another. They can look pretty similar.
Somebody wants to know, would Himalayan salt, which has more minerals, burn a different color than sodium chloride salt?
The flame would probably look the same because it's 95+% sodium chloride, but some of the other minerals in there, if there are other metals in there, could give it, if we looked at it through a spectroscope that had fine enough gradation, we might see that. Okay, I'm going to give you an unknown here. Ooh. So if I didn't know what this substance was, and I took this white powder, I couldn't tell that it looked any different from any of the others, I could do a test on it. We get that clear orange color. That was very similar to the salt, the sodium chloride. And if we looked at it under the spectroscope, we could identify those clear lines. So I would suspect, if I didn't know, but I poured it into the bottle so I know what it is, I would suspect this probably has sodium in it. And indeed, it is baking soda, which is sodium bicarbonate. Okay? The other reason I have the baking soda handy is we have the acid, and if any of that were to spill, I could quickly neutralize it. So safety things as we're doing all of this stuff. If I were to take sea salt, so asking about the Himalayan salt, we'd expect it to come out very similar in color to the sodium.
Zach, age 12, says, what makes the flames turn a different color?
Okay, again, it's back to that, the electrons, every atom has a different arrangement of its electrons. And because the electrons are arranged differently, as the electrons move between those energy levels, the heat in the flame excites the electron to a higher electron state, and what goes up must come down. And when it goes down, it gives off a photon of light. So if it falls this far versus this far, it's going to give off different colors of light, different wavelengths of light.
Yeah. Giona, I may not be pronouncing that right, age 11 says, do you only use colors in the rainbow when you do this? I think she's meaning, do you only see the rainbow colors?
The visible spectrum is what we think about. We can see a little bit of infrared and we can see a little bit of ultraviolet, but we typically talk about those. Astronomers would use this to detect the different gases that are in different stars or different nebula. So they could look at the emission spectrum, the light that's coming off of those, and detect what different gases are there. So they would look for things like in the UV range and in the IR range. They would look more in those. So ultraviolet light and infrared energy.
Yeah,
so
I can remember when I took organic chemistry years ago in college, and we had to identify unknowns.
Yeah.
This was part of it. You would look at the infrared spectrum. You would look at different spectrums to see what you could see, and it would help you identify the chemical that you were working with.
So those are used, but we aren't going to be able to see those in a spectroscope. We'd have to have special equipment that detects those types of things.
Last question,
right.
Eli, age 12. Is this method how fireworks are different colors?
That's a great point, and that's kind of what I was going to end on. So we can take advantage of this as a chemist. I can do these analyses to try and figure out what certain metals are and look at their signature. Different molecules even will have these different signatures. But a fun thing we do with this, like the packets that we throw on those, or the logs you can buy that have the sparkles built into them. Fireworks are a fun way of doing this.
Yeah.
So each of those different colors that you see in the firework, there we're using the gunpowder to create the heat energy to excite the electrons, and that energy is raised up and then given off. So every distinct color that you see in a firework is because a different metal is being used. So you'll see lots of coppers with the greens, you'll see the strontiums and the bariums, all those things to give different bright colors.
Yeah, all right, that's all the questions.
Thank you guys for joining us. Dr. Purdy, we want to talk about what we got going on for the rest of the day?
Right, so at noon, actually, I'm going to be giving the first part of a presentation on eugenics. So you might want to tune in to learn some things that maybe you haven't heard before in relation to abortion and Planned Parenthood and how all that kind of ties together, the history of it. I'll be doing today, and then tomorrow I'll be doing the future of it.
Yeah,
basically.
so parents might want to watch this one first, but a great way to bring those things to discuss with your teens and older.
Be good for them. And then at 3 o'clock, we're going to be doing another animal encounter, so fun animal for the day. And then at 7 o'clock, again, behind the scenes. So you'll want to tune in, have something new to do each day. We like to provide that for you. And so,
all right. Thank you guys for joining us. And we just hope, again, that you'll get out and explore God's wonderful creation.